Yeah, it's a pleasure and an honor to have Professor Clark here with us today to give us a talk on green chemistry and the circular bioeconomy. Professor Clark is a professor of chemistry at the University of York and is the founder and director of the Green Chemistry Center of Excellence at York University. He's teaching and he's been teaching also in several other countries all over the world, China, South Africa, and so on. And is the founding scientific editor of the world-leading journal Green Chemistry, published by the Royal Chemistry Society. And he is one of the fathers of the green chemistry in the discipline in Europe and in the world. James and I have been collaborating for a long time now, more than 10 years, and we've been collaborating on several European projects, European-funded projects. I remember we started collaborating on Sustoil. That was the first, back in 2007, I think, 2008. He's been working on the topic of green chemistry and sustainability transition for a long, long time now. He probably was one of the initiators of this research stream. And he's also very keen on interdisciplinary research, which made our bond very strong. So I remember collaborating with him as a vice chair of a cost action on food waste and food valorization, which was a huge project involving more than 150 researchers from all over Europe and the world. And that was quite successful, and it was really interdisciplinary. So I will stop here. I guess we can have also some time to chat after the seminar, after your presentation, James. So the floor is yours, and thank you again for being our guest today.
Thank you. Oh, it does work, yes. Don't get too close. Thanks to Giuseppe, a friend for a long time, and nice to hear all the memories. It goes back a long time, but lots of very good memories. So I'll start with an apology. I have a British cold, so my voice will drift sometimes. It's a little bit awkward, but anyway, it's something which I don't know if you have the same in Italy, but in the UK, we've had a lot of post-COVID. There's been a lot of like flu and influenza, cold, this kind of thing, and really, really common. So anyway, in case my voice breaks, it will come back again in a little while. So anyway, it's great to be here. I mean, it's as you heard, I've known Giuseppe, worked with him many, many years. And I came back to Italy because I was invited to Geneva, where they are similar, actually, because there it was for a PhD program, which they were just starting, I think. And it was they invited me there, and I thought, well, you know, because Geneva is one of those places which you can get to many ways, but none of them is very convenient. So I discovered, actually, I may as well come by Rome. So just come by Rome, and hopefully, as is possible, in fact, I could meet with Giuseppe, which is very nice. So let me focus. And this first slide, in a way, tells a lot, because it kind of describes where I've been for the last 20 years and where I'm going. So, as you heard, I founded something called the Green Chemistry Center of Excellence back in the 90s. So, like more than 20 years ago, 25 years. And it's a very large center with about 100 people, which is great. And in the last 6 months, very recently, I also started something called the Circa Renewable Chemistry Institute, which is Circa is the name of a company, and that reflects some of the emphasis of my talk today, which is the industry side of what I do. And Circa have sponsored a new institute. It's a virtual institute. It's not a new building. It's within the center, the Green Chemistry Center, but it gives us kind of a separate identity. And the focus, pretty obviously from the title, is on renewable chemistry. So the details below, maybe especially because I'm talking, I know as part of a PhD program, in recent years, I think I don't do so much direct teaching anymore. I still run the institute, but I've got more and more involved in entrepreneurship, commercialization, industrialization. I've always said that green chemistry, in the broadest definition of the terminology, has to work, not a theoretical subject. We can talk and debate, but it doesn't really matter. What really matters is making it work. The original term green chemistry came out of the US EPA in the early 1990s, so about 30 years ago. And they did it because they recognized that the chemical industry, when I say chemicals, I mean a broad range of things, including pharmaceuticals, plastics, and many other things, they were producing too much waste. And the waste was often dangerous, hazardous, and therefore the big driver for change was, can we produce less waste? And that also had alongside it, can we therefore use less dangerous substances in our processing? So that's always been a big part of green chemistry. But the concept is really broadened much more now and has a much broader life cycle or supply chain or value chain type approach, and includes feedstock issues and includes product issues and safety of products. And that gets us into all sorts of interesting areas, like working with farmers on feedstocks, and at the other end, working with retailers on applications of products, because chemicals, of course, go into everything, as I'll show you in a moment. The names below are just represent some of the commercial entities which I've become involved with, because I was frustrated by how slow it was to persuade industry to change. And industry doesn't like to change. You know, if industry is successful and they are making a lot of money, they don't want to change. So in the case of the big chemical industry, for example, in Europe, the biggest chemical industry in the world is called BASF, Germany. I've talked to them many times, and they don't want to change. I mean, they have a fortune, €1 trillion, they say, in infrastructure, embedded costs. Incredible. And of course, they continue to make a lot of money, so why change? So they know they will have to change because of legislation, customer pressure, and this kind of thing, but they're very slow. So I thought, well, maybe I could help by getting involved in some companies directly or starting some companies. And that was another part of this journey, which I became very excited about in the last 5 or so years. And that was the enthusiasm of younger researchers in my team to become part of it. The centre has had a lot of PhD students, a lot of postdoctoral researchers, many contract researchers, usually relatively young. And they actually, I could see that for many of them, it was not enough to do academic research and even some teaching. They wanted to become involved in the application, so commercialization. So those companies I've got down there, Cyrene is working with this company, Circa, the Circa Renewable Chemistry I mentioned. Adable is working with 2 of my 30-somethings researchers on plastic recycling, which is very successful. Starbon is led by another one of my young team called Rob, based around bio-based materials. And the latest one on the right is called eCarb. eCarb is actually with young researchers at Imperial College in London, not York. So just to give you an idea as to why I'm talking about these things. And as I said, it's also appreciating the fact that chemicals are everywhere. So they play a critical role in just about everything that we use. You are sitting on, you are wearing, you'll eat tonight, you drive home, whatever it is, take the tram. They are all what we say chemically intense. Without chemicals, they wouldn't work. And this is just a collection of pictures that show. But maybe some of the words there are quite interesting. 97% of all goods, everything, manufactured using at least one chemical reaction. And more than that, as I say, everything there contains chemicals. Sometimes the chemicals are natural and therefore are not, or maybe are extracted directly from, for example, from naphtha, from crude oil. But it doesn't matter. Everything contains chemicals, but it's not sustainable. So we've done this, we've built up this incredible range of consumer goods, which we use in the Western world. And now, of course, more and more people use in Asia, in Africa, around the world. And that means more and more demand for chemicals. But we continue to use very old methods of making them. We continue to use non-renewable resources, especially petroleum. And we continue to make products which are not sustainable. They are not compatible with the environment. They might even be toxic, as we are discovering now with more and more testing. So, not sustainable in products, processes, or resources. And we are using a lot more. This gives you some idea about trends. The one on the left is a trend until a couple of years ago anyway. It showed the number of publications. It continues to climb. It would maybe a little bit of the COVID thing has changed every statistic, as you know. But I mean, generally speaking, there's been a significant growth in the number of publications that talk about chemistry and report chemicals. So more and more chemicals available, millions of chemicals available. And we also have this incredible number of this value of chemical manufacturing. Because we have more things that we want, because more people want those things, and because there are more people on the planet, it means we need more chemicals. So that continues to grow. And this comes through in terms of mass. So, I mean, not just chemicals, but all the related industries like electronics, for example. The mass of things we use goes up and up and up all the time. The value, of course, also goes up. So economists are happy because they say it's all right, our economy is growing, which seems to be, a classic measure of what we think is successful. So that's okay. And we have had, anyway, maybe until recently, a growth in the consumption of carbon. So carbon is not just what we are made of, it's also what most things we make made of as well. So most of those articles I showed in my first slide are made with organic chemicals, which contain carbon, are carbon-based. Petroleum, of course, is carbon-based. Use that carbon to then turn that into other types of chemicals that we then use to make everything I showed you. The trend there is a bit uncertain because of this trend towards avoiding carbon, low carbon technologies, low carbon economy, alternative products. That's interesting. And I don't know for sure. It looks as though maybe there will be a leveling, maybe a reduction. It's driven, of course, by this real belief in the need to reduce carbon because, in particular, of emissions. Because, of course, it tends to end up as carbon dioxide and other sources of volatile carbon go into the atmosphere, causing the problem we all know about. It also, of course, represents a consumption normally of a non-renewable resource, petroleum. So there are two reasons at both ends of the value chain where we think carbon is not such a good idea. So what we do is we come up with alternatives, and we have now this incredible array of low carbon technologies. I could talk for hours just on this one slide. It's so interesting to look at what we are doing today. And also, it's all controversial as well, as it should be. Change should always be controversial. As I said before, the chemical industry and many other industries are not very keen to change. They are very conservative. And people, generally speaking, are not so keen to change. But people worry about wind turbines. They don't. I mean, I strongly believe in electric vehicles. I think I was one of the first people to buy an electric car. I made sure that my family also, when they buy cars, they buy electric cars. I think it's fantastic. But I understand it's problematic. So yesterday, when I was in Geneva, I didn't see, I think I saw one charging station. And so, my host was saying, well, I'd love to buy electric, but where do I charge? I live in an apartment. I'm lucky I live in a house with a nice garden. I can plug in my car next to my house, not a problem. And there are lots of charging stations. But obviously that's not true. When I was in Oslo a few months ago, even the taxis are electric. It's incredible. Everything's electric. So there is a big range, but the transition is happening. And there are some very interesting predictions. Governments under pressure to move towards this low carbon economy are saying things like, okay, we will have total electrification of the fleet. Whoa, okay. So, no more petrol cars, diesel cars from not so far into the future. Depending on who you talk to, sometime in the next decade, they're projecting there'll be a complete change. Interesting. Now, what does that mean? Well, people think, it means more electricity. I know people worry about electricity. Personally, I don't. I believe in, I think it was somebody in Shell who said a couple of years ago, we will soon enter a period of low-cost electricity. Because we can make electricity in so many ways, like wind turbines, it's not a problem, really. The short-term issues, but only because we are in transition from one source to another. But in reality, I don't think electricity is a problem. What is a problem is the things that go into the car, and especially the battery. Now, all of a sudden, we are going crazy about batteries. All of a sudden, batteries that we have in our laptop, in torches, in lots of things we've had for many years, all of a sudden, we are now talking about batteries for cars, and not traditional batteries, but these new, mostly so-called lithium-ion batteries. Okay, that's interesting. But batteries are a classic way of storing energy. So it makes sense, you charge them up, store energy, then you let the energy, you use the energy in some application, in this case, driving a car. And if you don't drive an electric car, I can assure you it's a fantastic experience. I mean, really, it's amazing, how good they are. So that's nice. But to make the batteries, we are using a lot of elements, parts of the periodic table we haven't really used before. So all of a sudden, we are now using lots of, not just lithium that we hear about, and even cobalt people talk about, but these very strange elements like dysprosium. I've been a chemist all my career. I hardly heard of dysprosium. the very unusual elements, gadolinium, wow, all of a sudden. And wind turbines, you can see again, good old dysprosium is there again, praseodymium. These are really unusual elements that have not been used much before. Now we are using them. What does that mean? Well, it means we have to find them. Where are they? Well, they are not necessarily so obvious. And we need to find more. Lithium, people talk a lot about lithium. I understand why. Lithium is now part of the current generation of batteries. That could change, by the way. It could change. We could switch to other things. It may not always be lithium, but at the moment, lithium is the problem. Next 10 years' time, it might be some other problem. I don't know. But anyway, the point is we are using a lot of elements we haven't really used so much before. That has an issue. Then there's also, I don't want to talk much about nuclear power. Again, I could argue about this. Personally, I'm not a fan of nuclear power. I think it's got problems all across the value chain. But anyway, people are using it more. Solar, of course, is great. And again, using a lot of elements. Very interesting to see what's going on in this alternative to carbon world. Just to kind of jump ahead, if you like, my concern in this whole space is I do believe in a low carbon economy. I think it makes sense. However, I believe change has to be intelligent change. And I see too much change which has not been well thought out. Oh, carbon's bad. Oh, so let's find an alternative. I know, let's use electricity. Okay. That means batteries, okay? Therefore, let's make 1 million batteries, 1 billion batteries. How many batteries do you need to electrify the entire vehicle fleet of the world? The studies done recently have shown very clearly we don't have enough of these materials. If we try to use the same types of batteries for all of the cars in the future, it's not possible the way we do things. And that's because, partly, of course, because of the way we do things. The way we do things is the way we've done for the last 100 years to make all the things I showed you before, which is we dig something out of the ground, or it could be oil, it could be a metal, then we process it and make something, like all the things I showed you before, and then we throw them away. The linear economy. Crazy, absolute madness. Doesn't make sense at all, totally non-sustainable. We cannot continue to do that generally, and we certainly cannot continue to do that for things that we don't really understand, like some of these very strange elements. So what we do, of course, is end up with an awful lot of waste. So a big part goes back to what I said before. So when, as I said, the green chemistry movement started a long time ago, the concern was waste. The concern still is the waste. People are now more aware of waste as a problem in terms of what it does to the environment, like in the sea, where you can see these only infrared visible plastic gyres, these huge areas of waste plastic, which are congregating in the seas. So we know that it's very bad in terms of pollution, but my emphasis has always been more a loss of resource. I always worry that, waste literally is wasted. It's a shocking loss of something. We have lost this precious resource. And, the resources we have on this planet are precious and should be treated as such. I do believe that we need to give much more respect to our resources. I know there are some crazy people going around talking about, it's okay, we'll go to the asteroid and mine the asteroids. There is a major organization in the United States with some very wealthy people backing it who believe the future is the asteroid. And, they've probably already bought and sold the asteroid several times. I don't know. It's just madness, to think that we can go somewhere else and solve our problem. Please stay here and solve the problem on Earth. We can do it. Nature does it perfectly well. We just need to learn how to be more compatible with nature. And of course, that means circularity. It means on the carbon side of things in particular, more and more bio-based. My bit of it is the green chemistry, which is some of the methodology, if you like, to achieve. This is just a picture one of those bright young researchers I was telling you about came up with. It's rather nice, I think. It compares bio-based carbon, which, like everything else, of course, should be reused and recycled as much as possible. The problem is everything ends up in the environment. We end up in the environment. Everything ends up in the environment eventually. And when it does, if it's bio-based carbon, it can be renewed by nature. Fine. If fossil carbon, of course, you can reuse it, recycle it as much as possible. You cannot renew it on a reasonable timescale. So it gets stuck in the reuse recycling. So we need to be really efficient on the reuse and recycling if we're using a non-renewable carbon, if you see what I mean. So that's another part of the work. So Adable, the company I mentioned before, has a big focus on plastic recycling, because whatever we think about the future, and we want to go bio, we want to go circular, absolutely, but we are now stuck with billions of tons of existing products. which are not going to go away. We need to find ways to get their value, the resource, back into circulation, back into. Though this, of course, is recognized. So, Pierre Giuseppe talked about some of the projects we've been involved with, and there is a growing number of projects in Europe, in the USA, in Brazil, in Asia even now, which is looking at this and trying to find ways to encourage it, trying to make sure that, for example, when we use biomass to make future renewable carbon, which is a big part of this, we should make sure it's sourced from a good place. There's good biomass and there's not so good biomass. And also to apply standards to really help this develop. I spent many, many boring meetings on the European Standards Committee talking about, how to develop. I understand standards are important, but the meetings are incredibly boring. But anyway, we did end up with some bio-based standards, which are now there in Europe and will be copied around the world, are being copied around the world, which is pretty good, I think. So that's that. Now, let's look at a bit more focus in terms of value. So value is quite interesting because, so we talk about biorefineries as the vehicle, factories of the future, which are the ones that will replace the petroleum refineries of today, and they will take a renewable source of carbon, typically biomass, which can be, in theory, could be anything, trees, grasses, straws, etc. And it basically converts that carbon into the things we want, all the things I talked about so far, including power. Now, this is where it gets a bit controversial because you can see there, the first picture, the small one, is electricity. I said before, electricity is not a problem. Well, trouble is people are very short term. They don't think to the future. So they have seen short term problems with electricity. And they decided, I know, let's stop burning coal because coal's bad. Let's burn biomass instead because biomass is good. Okay, but once again, not well thought out. So I live not so far, maybe 150 kilometers from Europe's largest biomass power station. It was Europe's largest coal-fired power station called Drax. They now burn over 10 million tons a year of biomass. 10 million, that's a lot of material. That's a lot of material. Where do they get 100 million, 10 million tons of biomass from? 20 million, whatever, Where do they get it from? Well, the answer is not from the UK, not from Europe. They get it from the US. They get it from Canada. They get it from wherever they can get it from. But they tend to get it from, especially at the moment, from the southern United States and western Canada. So it's shipped halfway around the world to then be burned. That is a classic example of what I say is not an intelligent use of a resource. So again, that's a long story, but that's the heart of it. The value is significant, 75 billion euros, they reckon. The value to the farmer who sells the biomass. So, okay, some of the biomass does come from farms, and the farmer's very happy, of course, to sell their biomass for 60 euros a ton because it doesn't. At the moment, all they can do with it is maybe some animal bedding, a little bit of animal feed sometimes. So it's not so great. But if they start, say, making liquid fuels, like bioethanol, it starts getting a bit more interesting. And the real value comes from when they start making chemicals, what's there called platform chemicals, which I'll explain a bit more in a minute. Platform chemicals are the building block chemicals that feed everything. So at the moment, our platform chemicals in the world are things like benzene, propylene, butylene, butadiene. These are the things that we've used for 100 years to make everything from, really. They come from oil. Now, the future change, and these are the possibilities. Now we talk about different platforms. But the point is that when you make chemicals, because chemicals are so much more valuable than energy, you make a lot more money. So the farmers gain, everybody gains, really. You make more environmental savings as well, because making chemicals at the moment, as I said before, is not very green. And then the idea, just for information, a bit more technical here, is you take the biomass feedstock, you turn it into a platform molecule, and from there you make everything. All the chemicals in the world, all the... Now that represents about 1 billion tons a year of carbon, total chemical in the world. I don't know what the value is. The value, I think, is something around 5 trillion. Anyway, it's huge. I have some rules of if you're a chemist, then you start thinking about, well, the details of the steps, the transformations. You have to be careful. You don't make this too open, too subject to some of that non-intelligent thinking I was talking about before. They're just lots of chemical structures. Just gives you an idea. The ones in the red box are the current platform molecules. Don't worry about what they are. The point is that there is a small number of molecules that have been our building blocks for a long time. And now we look at the possibilities from biomass, and there's a lot. Believe me, that is not all of them. There are many, many more. And what are the challenges in this whole area is choosing the right ones. That's what's going on today, and it's very interesting, very challenging. The estimating pH set we may have seen before goes back to the cost program, that great program we had. It was really good fun working on food waste. And this gave us some information about mapping, gave us some idea about resources. And also, I think, made us appreciate. So when we talk about biomass, people talk about trees. They think about trees. And of course, we have a lot of trees in the world. Absolutely. Yes, that's true. But there's also, of course, the food supply chain waste. That's important. And food supply chain waste is what I'm particularly interested in there is the stuff that we cannot eat. So the stones, the peel, all those sorts of things, I think, are really important. And we can't eat them, so let's use them to make chemicals. Just to give you an idea, remember what I said before, we currently use about 1 billion tons of carbon to make all the chemicals in the world, all the plastics, the solvents, the pharmaceuticals, everything. We already have about 3 billion tons a year of that inedible food waste all around the world. I think we could make a lot better use of it. And this, again, another project which goes back to StarPro Bio, another one we worked on together. And this was just giving some idea about, okay, so people need guidance, just saying, let's use biomass. Where do I go? What do I use? Okay, so there is obviously there's different types of biomass, and trying to make decisions about, which type of biomass and where and so on is not trivial and needs thinking about. Of course it does. Let me just talk a bit more about applications now, because this is where some of those new technology companies I've been talking about become important. So the biggest users of chemicals in the world are solvents and plastic. Plastics, of course, is number one. 10% of all the oil in the world goes into plastic. About 5%, maybe a few percent, a bit less than that, goes into making solvents. So we use incredibly large amounts of plastics solvents. And at the moment, 99% come from petroleum, therefore are non-sustainable and create environmental problems and waste. Solvents is big. I mean, okay, I won't dwell on this too much, but I mean, I'm sure you realize that solvents are used like everywhere. Paints, of course, is still the biggest area, but lots and lots of companies, most companies use solvents. Total market value at more than 20 million tons a year. I suspect it's more like 30 million tons a year. I won't dwell on this, but just to give you an idea about drivers for change, why would people want to change? So if you're a company, you're using a solvent for cleaning, for some process application, some product formulation, many companies are, and, why would you change? Okay, well, there's several reasons, of course, but the one that's possibly as important as any today is legislation. And legislation is forcing change, because legislation is now challenging every chemical we use and saying, is it safe? And the answer in many cases is no. In fact, an increasing number of cases is no. Many of the common solvents I used routinely in a lab when I was a student, no way, far too dangerous. And of course, the same is happening in industry. So, for example, big decision 2 years ago, Walmart, the biggest supermarket in the world, they said, I want no more, and it shows one of the solvents here, which is called, in the red list, the hazardous list, there's one there called NMP, just one example. And they said, I want no products on our shelves containing NMP. Now, actually, NMP is widely used for many cleaning, paints, formulations. All of a sudden, no more. Now, when Walmart says something, people react. And that disturbed many, many value chains, which is great from my perspective. We need someone to make a difference. So legislation is forcing that change. And also customer pressure. Customers get more and more concerned. So the point is, there are lots of solvents which people have used for many years, which are not safe. Now, back to food supply chain waste. Is there anything in there we can use? Yes, there is actually, called limonene. And limonene is, we've known about limonene for many years. You can make, every time you peel an orange or a lemon or anything like that, you can smell the limonene. Very nice. Well, limonene is a great solvent, as it happens. From a chemist's point of view, it's a very unusual molecule. Nature doesn't normally make molecules like that, but it does, and limonene is great. It's a fantastic solvent for some applications, good for cleaning, for example. We looked at this a lot, spent a lot of time in Brazil, for example, where they grow half the world's oranges, make half the world's orange juice. Every time you peel an orange to make orange, or squeeze an orange to make orange juice, you are left with a peel. What do you do with orange? The answer is not a lot. Well, actually, so orange peel is a great source of limonene. So let's convert the orange peel to limonene. It seems obvious to me, maybe to you, but to farmers in Brazil, they weren't so interested. Why? We already have a working model. Let's leave it at that. So Anyway, they are juicing. They are making some limonene from oranges around the world. If they were to make more, if they take all of their citrus, convert it into all the limonene they could make, could they have enough limonene to, for example, replace one existing petroleum solvent? The answer is no, just solvent. Incredible. Even so, China, for example, which actually grows a lot of oranges, about 6 million tons a year, even if it juiced all of its oranges, which it doesn't, and got all the limonene, it might displace half the toluene. And that's where there's lots of oranges grown. So, wow, okay, so we can make it a little different. It's worth it, but it's only a small effect. Okay. So we thought, actually, it's not enough. Nature is not giving us enough natural solvents like limonene, not many others really. We need some other approach. This was a methodology. It's getting towards now the commercialization I was talking about earlier with my friend James Sherwood, a very bright researcher in my team. And we worked together to come up with something which said to industry, okay, guys, you want a green solvent, you have to have a green solvent. How do you choose? How do you find one? So we had this thing called Sustainable Solvent Selection Service. That's led to all sorts of interesting commercialization. The most famous of which is something called Cyrene. And Cyrene is a molecule, made from wood, like sawdust. And a nice story, because about 9 years ago, no, more than that, 12 years ago, I was giving it's COVID effect, you see, I lose years. I was giving a talk at a public science meeting in the north of England. And first time I met Ellen MacArthur. Ellen MacArthur became world famous for her work in the circular economy. Ellen and I worked together for several years, and she started up this big movement called the Ellen MacArthur Foundation. Anyway, as part of those early discussions, I was interviewed by various radio stations, including by the Australian Broadcasting Corporation. And a little while afterwards, I was contacted by some guy in Australia saying, I've heard your presentation. We've got an interesting situation. Can you help? So this guy came to me from Australia, from Melbourne, and he said, I've got this platform molecule, one of those, that I'm making from woody biomass. I don't know what to do with it. An interesting green chemical looking for a home. So the idea was, I thought, let's convert this into something that might work as a solvent. Take my word for it, it's true. And it does. It replaces NMP in many, many applications. And the rest of this slide is just the methodology, how it actually works in practice. It works in lots of applications. We found it was great for graphene. You've probably heard of graphene, one of the really exciting advanced materials. It's great for making membranes and all sorts of things. It's been used for many, many applications. And that's led to, first of all, it led to a small production plant in Tasmania, a very beautiful part of the world. Not many people have been to, just south of it's an Australian island, just south of Australia before you get to New Zealand, basically. And there's a lot of wood, and they have a so-called paper and pulp mill where they make paper. I've made paper for many years, owned by a Norwegian company called Norske Skog. And like most paper and pulp companies, they were struggling. People don't use so much paper. What do we do? So we had this idea of working with them to take some of their infrastructure, including the trees, and making this molecule. Now, it never got big there for various reasons. It's small scale, about 1 ton a week, which is actually very small scale. But it was enough to make enough chemical to send out around the world for people to test. Lots of people found it very exciting. Won a big award in Europe. The BBI is a European program. And now we are making 1,000 tons a week, 1,000 tons a year in a plant in France, which is an old coal site, ironically. It was a coal-fired power station till now, last year, when they're now converting it into this green chemical manufacturing plant. This is the first of many. The master plan is to have about 90,000 tons a year being produced by the end of the decade. It's great. It's very exciting to see something work. Now, why did this work compared to other things? Because I said things tend to be slow, industry's slow. Because it's a new company. Because it was a new company run by a small number of guys who are really keen, very enthusiastic. They weren't driven just by the bottom line. They were interested in the environment. They were backed by lots of very wealthy, but again, very sincere people, I believe. And so it worked. It's very, very exciting. But it wasn't enough. It's one green solvent in this massive space of millions of chemicals. Well, okay. So what's next? So I talked about toluene before. this very large, can I have some more water, please? Very, very large volume. Toluene is about, I think it's over 1 million tons a year, thank you, of toluene is sold every year. It comes from oil, directly from oil. It's very cheap. It's great for a lot of things. I won't go into all the details, but it's used for a lot of applications. But it's now known to be basically it's toxic to the unborn child. It's a so-called reproductive toxin, like many other things like NMP, for example. So therefore, it needs to be replaced. So we were looking for an alternative, and we used some European funding to come up with another thing called TMO. Don't worry about the details here, but TMO basically is a completely new chemical, which is green. It can be made from biomass. It's totally non-toxic, passed all the tests. It's biodegradable. It's totally safe. It never decomposes. Many solvents are dangerous because they will decompose. This one doesn't. And it's, of course, useful for many applications. To take this forward, we had to basically do it through a new company, which is what we call Addible, which is really there to do other things like plastic recycling, but is also there to help develop this new solvent. So it's brand new. We're in the process of getting investment to move forward and start manufacturing at a large scale for the future. That's quite exciting. And the value chains we're talking about here, which are fundamental to all this, I mean, we have to have value chains. We have to have feedstocks and end users. So to do this, we've got together some really good partners, Norske Skog I talked about, who supply the wood in places like Australia, but also in Northern Europe. We wanted companies like Circa I mentioned to produce the platform molecules that we then use to turn into new green solvents in this case. And there are lots of other companies who are interested in using the solvent for different applications. And there's also, I mentioned plastics, of course, just briefly, let me say about plastics as well. Plastics, of course, is another massively challenging area. And it's quite, I think plastics is so big, I think we need probably several approaches working in parallel. So part of it is to replace traditional petroleum-based plastics with, again, bio-based ones. And this is going on in many places. Brazil is world leading. You can buy bio-based polyethylene now. And probably in the near future, you'll be able to buy bio-based polypropylene and other things. So that's quite exciting. We've been involved in projects, for example, here with another small company called Bio to make bioplastics for packaging type applications. That's working pretty well. And again, you've got the same principle, biomass, for example, straws, wheat straws, into so-called sugars. The sugars are then converted to chemicals, and then you have the bio-based plastic. So that's the kind of the route to make those things. But the other parallel route I think we need to use goes back to what I said before. We can't ignore what we already have, what we already do. Even if we change tomorrow to all bio-based plastics, which of course won't happen if we did, but even if we did, we're still stuck with a lot of waste plastics already out there in this building, in the vehicles driving past, and in 1,001 other applications. What do we do with all that plastic waste when it comes to the end of life? And of course, we think about plastic waste. We can think about it in several ways. Plastic waste is a source of carbon. It's a source of chemicals. It's an organic material. It can be used the same as oil. So actually, to me, one of the most obvious things to do is to use it instead of oil. And again, you talk to people like BASF and they go, yeah, but we're not so sure. It sounds a bit complicated. Where do we get all the waste plastic from? So logistics becomes a massive issue. How do you get enough waste plastic together to make a seriously large chemical production work? That's a big challenge, I agree. So you can make fuels, liquid fuels, as long as we want liquid fuels. You can make chemicals. You can make materials. You can make hydrogen, which of course people talk about the hydrogen economy. Lots of interesting possibilities. But the reality is that despite all this potential, we have to recycle. I mean, whatever we do in the future, we have to find a way to recycle plastic waste, because it's such an enormous amount of carbon out there, causing all sorts of hazards in the environment. I mean, we know about now the plastics in the seas. They're finding plastic everywhere. One of my hats I wear is working with people at Fudan in Shanghai in China, and they've been looking at sewage. And the amount of plastic, microplastic, coming through the sewage system is frightening. And now, of course, they've found plastic inside us. Even in the veins, actually, they've found microplastics now in our veins. Really disturbing. We don't know what it's doing, but personally, I believe in the precautionary principle. I'd rather not have something if I don't know what it's doing. In me, that was a bit dangerous. And just to make it worse, the plastic is rarely just a polymer. Plastics normally contain other chemicals, like so-called additives. A typical piece of plastic will contain, the plastic in this bag has a color, obviously. It's also got a plasticizer. It'll have a flame retardant. It'll have some residual catalyst from how it was made. Probably other things as well. Typical plastic is a mixture of several things. So when this gets in the environment, if it did, breaks down, it could release those chemicals. And they are almost certainly going to be dangerous. Flame retardants are known to be so-called persistent organic pollutants. Phthalates are known to be toxic. So, wow, the problems we have now created in the environment, and we're just beginning to learn about what that means to us, is scary. So we have to find a way, capture the plastic and recycle it, get the value back again. But we don't recycle things. This is the periodic table, and it's basically, it shows from an element point of view, what we recycle. Just an example, because I always think it's very telling here, because we have this amazing collection of elements in the world, and yet we only recycle a tiny number of them. Ones in red, we don't recycle, essentially. So, and then those, by the way, the ones in red on the right-hand side, GA, GEAS, they are vital to the electronics industry. Without that, we don't have electronics. And yet we carry on using them regardless. You've got other ones, the red ones below, the so-called lanthanides, CEPRND. They include the sort of ones I mentioned before, going into batteries and wind turbines, solar cells, that kind of thing. We don't recycle them. We only recycle a few in the middle, like for jewelry and that sort of thing. It's really bad. We have a terrible tradition of recycling. We're trying to say to people, let's recycle the plastics, etc., and our food waste. Not going to happen, is it? We need to be much more clever about how we make this happen. So our history is bad. It has to improve quickly. Just from an availability point of view, by the way, in terms of, if we carry on the way we are, the linear economy, we carry on using virgin metals, where they're all going to come from? Well, the answer is not from here. They're coming from Africa and China. And when a kid is talking China, they all smile. Of course, they know. They have a fantastic resource space, as they do in Australia. Australia is not really being affected by the global recession because their reserves are phenomenal. The Americas are pretty good as well. Europe is badly resourced. We don't have many. We are finding some. So in my country, we have found some lithium recently. But, just because we found it doesn't mean that we can get it. It can be very difficult to source. It'll probably cause some real environmental harm. So it's more than just finding it. It has to be processable in a safe, environmentally friendly way. Now, this is a bit of a diversion, but it actually brings up another issue, which is to do with, because whatever you look at, when it comes back to biomass and carbon and stuff, we talk about using biomass to make chemicals in the future. Great, okay, sounds good. That means growing stuff. And I talk about, well, don't use the stuff that we use to make food. Let's use the stuff we can't eat. Fine, okay. But that probably needs more land, more people will want more food. That's good in a sense. More biomass will be grown and processed, will it? Well, actually, this is what we published in Nature last year with my friends in Shanghai. This shows actually, no, because, so-called BECCS, by the way, is biomass energy carbon capture and storage. BECCS is the modern way of working with biomass in a power station sense. The logic is you burn it and you capture the carbon in some way. That's totally, it doesn't emit any carbon. That's the theory. I tried to work on that, which is okay, better than I suppose just burning it. But the reality is, this study showed climate change is going to reduce the amount of land available to us for growing and the crop efficiency, the efficiency of the land growing crop for various reasons. As the land gets warmer, the water residence time goes down, and also the enzymes that do a lot of the work, they become less active, often die. So actually, we are killing the land. Climate change, we talk about in the context of lots of things. We don't necessarily think about it in terms of arable land as a big impact. So actually, we have enough problem just feeding ourselves. We're thinking about also using that stuff to make chemicals. Maybe that's pie in the sky. I don't know. Anyway, it's tough. And back to metals again in terms of resources and issues. The problem with, again, carrying on as before and just using what we haven't used already. Some people say, if you look at the Earth and you calculate how much lithium is there in the Earth, and the number is enormous. It's far more than we'll need for the next million years. Sounds great. No, it's not. Where is it? It's a long way. We've taken all the easy stuff, like the oil. We've taken the easy oil. Now we have to find more. That means bigger holes, deeper holes in strange, difficult places. You go to the Canadian tundra, some of the oil is now coming out of parts of Canada, which is really difficult environmental areas. Just the North Sea in my country, which they have been taking on, is very dangerous. You saw what happened in the Gulf of Mexico several years ago. Again, I talked to the chief engineer of that project. And he said, well, the trouble is, we were drilling for oil in a really bad place. It's very difficult. It was inevitable there'd be an accident. They carry on doing it. So every time they go for more metals, more oil, it gets more difficult economically, environmentally, safety-wise as well. And just processing the ores, traditional ores, is vastly consumptive. 3% of all the electricity in the world goes into crushing ores to get the metals out. So let's think about, we talked about biomass, we talked about food waste. What about metallic waste? What sources of metals are there we don't use? Mines, you go to any mine, I've been to mines in South Africa, you can see the metals running down the waste stream. Terrible waste, terrible waste. The landfills, I said there's not much in the way of virgin metal in Europe. There is, it's called landfill sites. The landfill sites have got enormous amounts of metals in there, waste computers, etc. And of course, waste itself, another way of looking. And even along the roadside, there's lots of metals coming out of backs of cars. There are ways to we have technology. One of our companies, again, called Starbonds, is a way of capturing metals. Fighter cats, another way we've been developing, working with friends in New Zealand and earlier on in the US and Canada, to find ways to use plants. Plants are natural scavengers of metals. Incredible. The so-called phytomining and phytoremediation is using plants to capture metals from the ground. They will take enormous amounts of metals into their roots. You can then harvest the flowers, plants, biomass, trees, for example. They grow very nicely. So willow is one that we can use. Lots and lots of interesting. So that's all great. So there are ways we are developing, exciting new methods, try and get some of those waste back that we have to valorize and also replace traditional resources. But as I said, it's all very slow, and it's needs to jump more from the idea into the commercialization. So, and there's also the challenge I said before about the complexity, about the additives, and that generally is an issue which I wanted to raise briefly here, which is, as I said, plastics contain lots of different chemicals. Everything contains lots of different chemicals. I will point to things, ordinary products in your house. Next time you have a shower, look at the back of the shower bottle, shower gel, and you'll see a big list of chemicals. Wow. The most I've seen is 50. I defy anybody, even in the industry, tell me what those chemicals are. They don't know. I don't know. They just add more, keep adding more. Some are there to clean, obviously, keep it stable, to make it flow nicely. But beyond that, really strange. So complexity is the enemy of circularity. If we make things really complicated, trying to recycle them, get value back, is much more difficult. I won't dwell on this. It was just some ideas which Klaus Varner and I came up with in a science article a couple of years ago, trying to find ways to basically get more green chemistry into circularity. And avoiding complexity is very, very high up on the list, in my opinion. It's difficult because it's what formulation guys who make together those shampoos and shower gels. We're working now on one project we're looking at is nail varnish. When you use nail varnish, close your ears now. The chemicals that go into nail varnishes is amazing. And they're all leaching out, by the way. When they put them on your nail, they don't stay in your nail. And people are beginning to realize that now. Some of the worst ones coming out of certain parts of the world are particularly hazardous. So everywhere you look, we have this complexity challenge of lots and lots of different things going into ordinary articles, causing all sorts of problems. I won't dwell on this. It's just realization. And there's the team, not that recent, about 2 years ago now, just before COVID. But the point is, it's a big team, lots of interesting good guys all over the world. We very much focus on research all the way through to commercialization. There's our new institute I mentioned before, not much to say about it, really. Brand new, just getting going, really. We love outreach. We love engagement, public engagement. We have a comic. Well, we have a comic. We work now with people in other universities, Teesside in the north of England, come up with a comic book. The first issue came out 2 months ago. It talked about our solvent Cyrene and the green kit. The next one's just coming out now, which is talking about the plant idea, the plant capture of metals. And the third one is going to be about batteries. And the idea is to try and get this across to young children. It's already available in English and French, not Italian so far, as far as I know, but that might change. And it's great, because we're talking here about things that won't happen fully until quite a long time in the future. Therefore, engaging younger people from very early in their own value chain, I think, is a big part of it. Many thanks to a lot of people, the team especially, lots of funders from around the world, but especially the young guys who made all this work. Thank you very much.
Thank you, James. Very interesting and inspiring talk, I would say. Well, we at Unitelma Sapienza and the Bioeconomy and Transition Research Group are in a way acquainted with what you presented, but we look at a different perspective. We look more at the social economic side of it, which is, of course, always underlying in your presentation. Yeah. So I would like to open now the floor for some questions. If this is okay with you,
Sure.
it's 4 o'clock.
Absolutely.
Yeah. So don't be shy.
What I talk about when I say the great rush to be second. So who's going to be first?
Exactly.
It's a change, you see, like changing. I said before, industry is very slow to change. Once one company does it, of course, the rest will follow.
True.
We could persuade one big company. So maybe Walmart, I said before Walmart, that's interesting. And there are some examples of some companies, Carrefour, quite good as well. IKEA, we need some of them, though, I think, stand up a bit more, shout it out, not just do it, but also talk about it. Everyone should be doing it.
So I will make you a question. You mentioned the Star Pro Bio project and the needs for standards and for certification schemes. Boring in a way, but very much needed, I think. And this goes to the role of companies in this transition process that needs to be monitored quite closely. And standards and certification schemes, I think, are quite valuable tool for doing this and avoiding greenwashing. I mean, my question is, from your experience, how much do you think that these large companies are truly committed to the transition? They see it as a business opportunity, or they are actually more trying to adjust to a change, but in the less expensive way, and trying to do it mostly through greenwashing?
I think they're probably more sincere than they were before, but they it's not their top priority. I saw this recently with my company, BP. BP, the big oil company. BP said BP have always been very involved in the bioeconomy. I remember 20 years ago in a meeting in York, someone from BP talking about biobutanol, bioethanol, very early days of biofuel. And they had said they were going to commit more and more into renewable, less and less oil. That completely changed like last week or 2 weeks ago, when they said, oh, actually, they're making now a fortune from the oil price being so high, the demand for energy, all the problems with what's going on in Ukraine and Russia. So, of course, when they see a financial opportunity, everything else is forgotten. So, the problem is, I think it's in there. They're now aware of it. They now understand it maybe a bit better than they did. They see it, but they don't see it as being immediate. They always think, oh, we can do it tomorrow. They will never miss an opportunity to make money now. So are they really committed to this? Maybe they're committed, but the time scale, what's the time scale? I mean, how long do we have to? And I don't know how long we have to wait. It's like saying, when will we reach the tipping point? Some of the things I read these days about what's going on in the oceans, I mean, I wonder if we've already passed the tipping point. I don't know. You can't say that, otherwise you'll really scare people. But I don't think we can carry on just saying it's tomorrow's problem. This is the real problem now, is trying to get companies to take it on board now and say, whatever happens, it's the world economy to global issues like Ukrainian war, we will continue. Direct. Small companies, yeah, because that's what they're some cases, because that's how they're set up. The big companies, I mean, they, as I say, they are more aware. They do recognise it is important, but I'm not persuaded that they recognise it's important today, or not as important today.
Thank you. Any other question?
Yeah.
No, I was just telling that it will strongly depend on on legislation, you know. So if they need to be compliant, then of course they will do something more. And if they are really committed, we don't know. Anyway, if they need to comply with legislation, they will be more quick, let's say. They will implement more quick actions.
Yes and no, ultimately, but again, when? Legislation, in my opinion, like REACH, European legislation, is too slow. You know, they have this pipeline now for 15 years. But now we know now which chemicals are dangerous to use. But companies are given years to change. They will say, oh, it's okay. Should change in 3 years, 5 years. So, and companies, of course, will take advantage of that. And all the time, industry seems to be fighting it. They're like, as in, they don't work with legislation in this case. They want to fight it. And that fighting, of course, okay, they probably know they won't win ultimately and delay. So a lot of the chemicals I mentioned today, which we know are toxic and are in everyday use, will carry on being used for another few years because legislation is weak. I mean, I think actually Europe is I've always found Europe's great for starting things, but it's not very good at following them up. So I see now in China, Korea, in Japan, I see new types of chemical legislation in my world coming up, which are much stronger. You know, wow, they're having a big impact. So I worry we'll be left. Great idea, guys, but if you pushed it quicker, harder, make a difference. A lot of it comes down to the aware of REACH, the chemical legislation. Yes, so REACH, of course, is probably the most important chemical legislation in the world, and it's been copied around the world. Then China REACH, Korea REACH, Japan REACH, and so on. Very, very good. Great. I remember a long time ago, so maybe around 2006, 7, say 15 years ago, when they were still debating, before REACH became law, they were still debating it. I remember these discussions, sitting at a meeting, and the industry would come along and say, oh, it'll kill us. It'll destroy European industry. We will have legislation which is tougher than anywhere else in the world, and therefore we will no longer be able to make chemicals, use chemicals. Crazy. End of industry. And then I remember one guy from, I think it was Korea, gave a talk and he said, we think REACH is protective towards Europe. What? Because, of course, he said the future is green. You can be first to have green chemicals in your products, green products. You'll win. You know, the markets will give you, oh, suddenly thought, gosh, yes, he's right. It's actually a plus for industry. But despite that, it's been so slow to make it work. And so, yeah, I don't know why exactly. I mean, okay, maybe, you know, some people say a benign dictatorship is the best way. I personally don't think that, but it's like, you know, maybe because, you know, these other places like China, for example, they just say something, they do it, that's it. Industry is told by the leader, you change, okay, no choice. In Europe, it's like, we'll have a discussion about it. And then we'll, you know, test the law and so on. I don't know what the answer is, but I mean, I think I believe that's a fact, is that we are great at discovering things, including the green technologies, by the way, but very bad at exploiting them. We are slow to take advantage of our early ideas, and that could eventually kill us. Yeah. Yeah.
Thank you.
It's a news about 2 days ago that European Union will ban the selling of new machines, of diesel machines or carbon machines, by 2035, if I'm not wrong. So in 10 years from now. Yeah. So 2 things. First, do you think that it's actually doable? And second, if we assume that there will be only electric cars, vehicles, what's the dark side of these vehicles? I mean, what's the environmental impact of the electric batteries, if there is any? Because I'm not in this.
Sure. Field. Good questions. Is it a good thing? I think probably yes. I think what I said before was we're too slow. At least this legislation sets a date, a target. And it's very quick, really, when you think about what needs to be done. So I think probably having a real target is necessary. It's like with recycled plastic. I talked about recycled plastic. There is now legislation which requires many plastic objects to contain so much recycled plastic. That's forcing industry to find ways to make recycled plastic. So yeah, so I think the basic concept is sound, is good. And a lot of countries, my country, many countries around the world are doing something similar. That's great. Okay. But back to my original point. However, it needs to be better thought through. We need to think about this in a more intelligent way and just realize, okay, what are, as you said, what are the new environmental impacts? I mentioned some today. I mentioned, we are using more obscure, unusual elements. And do we understand where we get them from, how we get them, what the environmental impact is of mining them, processing, purifying, and recycling? Personally, I would say that every company from now on who wants to make batteries, for example, you must have a strategy in place to take the old battery and recycle it, get the resources back again. They tried to do that with electronics manufacturing several years ago. It never really worked. This is a great opportunity because otherwise it happens so quickly, so vast, we'll lose track. And of course, already, people are talking about importing batteries from. Batteries are heavy. Wow, if they start importing most batteries from, I don't know, Asia, that's going to have a big environmental impact. Transportation costs and so on. So there's all the value chain, where they're coming from, how are they made, what do they use, and at the end of life, after they've finished in or whatever, we need to have a technology available, and including the whole collection side of things, to get the resources back again to make new batteries or something else. So this, I would say, great, but let's make sure all the industry supporting this is genuinely circular. And once again, at the moment, I worry we invent the concept of circularity, but we don't know how to enforce it.
Thank you.
Other questions?
Now is it working? No, now it is. Now it is. It was just an observation. Previously, Enrico pointed out about top-down incentives, which is legislation pointing towards the chemical producers or everybody involved in the value chain to switch towards greener practices. I was wondering if, in your opinion, are there any implementable or even potentially successful strategies which could be implemented bottom up, which is consumer pressure, basically? And to what extent, and I don't know, maybe the role of education and, just instructing people about the damages chemicals can make and so on could have an impact. I don't know, just if you have any point in this or any.
Well, I think you mentioned one key word there, which is education. I've always believed that, of course, as I said earlier, you need to think about this long term. And therefore, try and bring up a new generation of children who will become the future, of course, with a natural belief in sustainability and circularity and all these things. So they will naturally follow this through. Trying to educate, re-educate, if you like, normal people around us now is obviously much more difficult. Something like recycling. So people have learned in many countries about recycling is good, they think. Recycling is good. So interestingly, we did a survey a few years ago. We asked people, just ordinary people in the high street, we said, you know, most people did not understand the difference between recycling and degradation, biodegradation. They had no idea that we were different. So should a plastic be recyclable or biodegradable? It's actually a difficult question. But most people thought the same thing. So there is a fundamental lack of understanding to what this all means. So take an electric car. So you buy an electric car, and what do you need to, in the package, if you like, for the consumer, the buyer, the driver, the owner, to do to help ensure circularity of the batteries? Interesting. Well, I suppose you could have a situation where maybe you don't own the batteries. Maybe this ownership thing is a big point. You know, maybe we say, okay, actually, you might own the car, but not the batteries. So therefore, you're responsible. You just let the batteries be wasted. You have to pay a penalty or something like that. I mean, finances, of course, ultimately are always the ultimate weapon. So, you know, that's we can talk about pollution and resources, but most people, unless it affects them directly, you know, they don't necessarily think about that. So I think, but the financial side, it may be more and more financial instrument. And I know the leasing thing, interesting the chemical world, there is a movement towards so-called chemical leasing. So when you buy something, which is like you buy a metal, some application, you don't buy it, you lease it. And so the original distributor, manufacturer of the metal, whatever it is, they keep responsibility. So that's quite interesting. We could test that more in the real world, see how that works out. I know it disturbs. It's interesting in the West, people have like ownership. You know, they like the concept of I own a house, I own a car, I own these things, and they put values on it, this kind of thing. Well, that's interesting. Maybe we could start shifting that a little bit. You do say own a car battery, you therefore have a financial responsibility that if you don't ensure the battery at the end of life is dealt with the right way, you have to pay a penalty. The alternative could be, I don't own the battery, I'll buy the car, I just lease the battery, I pay so much every year or something. So maybe that's a way, you know, we could think more clever financial instruments. I think the combination of that for current generation and education for the next generation is maybe one possibility.
Thank you. Yeah, I just want to add something about this question, bottom up, top down, and nudging that you were mentioning, and consumers. I think that we should be very careful with putting the burden of this transition on consumers. Because, of course, I mean, they are weak in terms of policy representation compared to big industries that can lobbying and push policymakers to postpone the implementation and the enforcement of regulation. But we should really be very careful in not frustrating consumers in this transition. Just to give you an example, we are now buying a new dishwasher at home, and it's a pain in the neck to find a way to dispose of the old one. So this is the point that you were making before. So extended producer responsibility. This works better than putting the burden on consumers. This should be a burden on the producer. When you are buying, when you are producing and selling a good that can be recycled in an effective way and can be very valuable in the circular. So this should be a burden of the producer. I think we should be very careful in pushing this on the shoulder of consumers, because it can be really frustrating for them. So yeah, this is something that we should. It should be balanced, I think.
There again, don't you believe that you should share responsibility?
Yeah.
We should have some responsibility.
Yeah, absolutely.
Ownership of this whole thing stands for part of their future, their children's.
Yeah. I mean, I'm completely in favor of shifting from owning to access.
Right.
This whole idea of sharing economies, I think it's one of the drivers of this transition, of course. But I really think that, I mean, we have large companies that have been experiencing extremely high profits over the last decades. Now they should be, in a way, they should be the drivers of also of this transition. Yeah. This is something that is you can't really expect that the consumer. I mean, it has to be shared, but in a way, this large company have to pay back this excessive profit that they've been making over the last years in this transition. Okay, I don't know if there is any other question. No. Okay, so.
New American plan for the for sustaining the transition. What do you think?
You mean Biden's green economy thing?
Yeah.
I've read a lot about it. I mean, I think the basic. You tell me. I've just read the headlines in terms of more investment in, more encouragement for. I've heard companies now talking about moving manufacturing to USA because of this.
Yeah,
sounds very good.
Yeah, and so now in Europe they are proposing a green fund, to be, let's say, more competitive. Otherwise, many companies will fly in the US. Anyway, do you think what do you think about public incentives? Do you think that they can really push to be, because as you said, we are too slow. So what is the role of public incentives in this? It can maybe really push or not?
So I think, okay, well, fundamentally, I do think that for these industries to start, they do need help. I mean, I've seen that real example of where, lots of companies have folded, collapsed because could not survive in the market because they're competing with old, established companies who pay for the infrastructure, have the markets, and so on. So therefore, how do you help those? So some of the companies I work with succeed not because of help, but because they have a group of very committed individuals. I had tea last few days ago with a lady in London who owns a ethical swimwear company. Very interesting conversation. And she was doing it all entirely because she believed in it. She was reinvesting her profits. She was on her way to Spain, where she's going to build a new recycling facility for old swimwear, gymwear, this kind of thing. Very motivated. But of course, that works in some cases, but you can't rely on the goodness of individuals or, this kind of thing to be enough. I think there has to be public encouragement in some shape or form. But as I said before, ultimately it has to be financial. Because why else? Companies can't afford to, starting something new, like things I talked about, the ones I'm involved with, building a new chemical plant to make a solvent they raised 55 million euros just for the first stage. The whole project will cost €1 billion probably. It's like, wow, to get that money is tough. There are some little incentives, some mechanisms for raising part of that, but you need to be doing it in an environment which is encouraging. I mean, to be fair, the plant they're building in France has got great regional support where they are, Northeast France. They've been fantastic helping them. They have problems, for example, but it's not always the case that they get this kind of support, and we need to. So therefore, you somehow need to get. Case of Biden, of course, he's got a big country with a huge manufacturing industry, and he can really, make it a good environment for people to. They've already got a wonderful innovation base. I mean, friends of mine in the States doing similar things to me, they can seem to raise money so much easier, even when it's a high risk. So in a way, he's helping to put the pieces of the jigsaw that really make USA. Funny enough, I heard, a friend of mine who runs an investment company, he's got financial backers in the US, and he said just in the last few months, he's found the American backers have now got really keen on bio side, bioeconomy. All of a sudden, they're now demanding They want to know more. They want to invest more. People working in the bioeconomy. So, and I guess that's driven by what Biden's doing. So that's interesting. So that can, so, I mean, of course, the USA is still a very, very important place, so what they do should have a big impact. I mentioned before Walmart and there are bits. But it's a funny country, the US, because ExxonMobil, I've always thought, they are the devil. They're the worst example. I used to work with them at one point, trying to work with them, and it was impossible because they were all obsessed about oil and money and, anyway, so, but having said that, they do have some of the best examples as well of green industry. And Biden will certainly help that. So, yeah, we have to move. Okay, make it competitive by all means. And say to Europe, if you like, if you don't do something, all the interested companies will move to the US. Maybe in the future it'll be China. I mean, I do think China is very important, despite the recent problems and their crazy president. I do think they're so important, and they are really motivated by the green economy, by the bioeconomy. I've been there many, many times, and I've seen some incredible things going on there. They will catch up and overtake us if we're not careful. So yeah, we have to, as I said before, we have to move, and we have to react. So the USA does it. Go for it.
So thank you very much, James, once again.
I don't know if I'm pressing the right one here. I'm trying to eject my